Right now, at this very moment, you are orbiting the sun at 30 kilometers per second. You don't care. You can't feel it. Now imagine someone throws you next to something with a mass 4 million times that of the sun, Sagittarius A*, the center of the Milky Way, 26,000 light-years from where you're sitting. You're dead. But here's the problem, you don't know you're dead. More precisely, the moment you die, those watching from Earth will see you frozen there forever, a ghost locked in time, motionless for billions of years. What did the universe do? It reached in, grabbed time itself, and bent it. This is not a metaphor. It is the core prediction of general relativity, experimentally verified to 15 decimal places. You thought time was a backdrop, a river flowing evenly, shared by everything. In reality, time is a rubber sheet. The greater the mass, the deeper it presses, the slower the surface moves. What comes next will make you permanently suspicious of the word now. Accept this counterintuitive fact first, without asking why mass curves time, not just space. In 1916, Einstein wrote down the field equations of general relativity. The equations solved one thing: the closer you are to a massive object, the slower your time flows. Not feels slower, actually slower. Slower in an absolute sense. Slower in a way that atomic clocks can measure. This is called gravitational time dilation. Get closer to mass, and your second shrinks. How real is it? Real enough that GPS satellites must correct for 38 microseconds every single day. Without the correction, navigation error accumulates to over 10 kilometers per year. When your phone tells you to turn left, its time calculations have already factored in Earth's gravity and orbital velocity. Every time you use navigation, you are consuming Einstein's legacy. But that's just the gap between Earth's surface and a low-orbit satellite, negligible. What about the edge of a black hole? A black hole has a boundary called the Schwarzschild radius, or the event horizon. Nothing inside it can escape, not even light. Near this line, time dilation is not 38 microseconds, not 38 seconds, not 38 years. It approaches infinity. Here lies a trap that trips up countless people. To an external observer, you can never reach the event horizon. To yourself, you cross it in minutes. Same event, two completely contradictory descriptions, both true. The universe allows both realities to coexist simultaneously. This is not a philosophical paradox. This is physics. Wait, it gets worse. General relativity provides an equation for gravitational time dilation. You don't need to memorize it, just know what it's telling you. The rate at which time flows depends on how far you are from the center of mass. One number to anchor the feeling: standing on a neutron star with 10 times the sun's mass, your time runs about 30% slower than a distant observer. This object is only 10 kilometers in radius, density 1 billion tons per teaspoon. Take a single breath there, and 1.4 seconds have already passed on Earth. Now move closer to a black hole. Sagittarius A*, for million solar masses, Schwarzschild radius approximately 12 million kilometers, roughly 1/3 the Sun to Mercury distance. This number is about to start compressing your time. Stand at 10 times the Schwarzschild radius, about 120 million kilometers, and your time runs 5.4% slower than an observer at infinity. Undetectable to you, but visible to an atomic clock. Compressed to 2 times the Schwarzschild radius? Time slows by 42%. Down to 1.1 times? Time slows by approximately 68%. 100 years pass on Earth, while only 32 years pass for you. Approach the event horizon further? Time approaches zero. In theory, hovering exactly at the event horizon, requiring infinite rocket thrust, physically impossible but mathematically valid, your time slows by an infinite factor relative to a distant observer. You become the universe's permanent exhibit. A figure frozen in amber for all eternity, visible but unreachable. What the external observer sees, You've frozen there like a photograph, light progressively redshifting, dimming, eventually vanishing into background radiation, but that moment of vanishing never arrives, because reaching the observer takes infinite time. You become a cosmic negative that never fully disappears and never comes into focus, pinned forever at that line. Now switch perspectives. You're in a spacecraft, diving toward Sagittarius A star. Set tidal forces aside for now, falling freely through the event horizon, what do you feel? The answer is, nothing. General relativity predicts that for a sufficiently massive black hole, the event horizon itself is not a visible wall, not flames, not radiation. Nothing at all. Local spacetime is smooth. Crossing it feels no different from crossing the edge of the solar system. This is the second cognitive trap. That classic image in popular science, the black hole surrounded by a roiling accretion disk, that's radiation from matter friction hundreds to thousands of Schwarzschild radii away. Not the event horizon itself. You've been looking at the wrong thing. The event horizon is an information boundary, not a physical one. The moment you cross it, nothing will tell you, you have entered a one-way region. Time keeps flowing, your heartbeat continues. But from this point on, not a single photon in the universe can carry you out. Every possible future trajectory points inward, toward the center. Every single one. Your future has become a location, not a moment. Outside the event horizon, you can choose up or down, left or right, your future extends in any spatial direction. Time is one dimension, space is three others, you have choice. Inside the event horizon, the geometry of spacetime itself has been rewired. What was a direction is now a deadline. Inside the event horizon, moving toward the singularity is no longer a spatial option, it is a temporal inevitability. Just as you cannot stop time from flowing, you cannot stop falling toward the singularity. Your end is not a place you might or might not reach. It is your future itself. This structure makes the universe more brutal than any horror story ever written. Wait, we sidestepped something. This is the final cut, and the most concrete one. Tidal forces. Gravity weakens with distance, which means your feet are closer to the black hole than your head and experience stronger pull. That differential will tear you apart. The magnitude depends on the gravity gap between your two ends. For stellar mass black holes, that gap is lethal. For stellar mass black holes, 10 to 100 solar masses, the Schwarzschild radius is only tens to hundreds of kilometers. While still thousands of kilometers from the event horizon, tidal forces have already shredded you into a strand of plasma. This process is called spaghettification. You won't even get to see the event horizon. You cease to exist long before you reach it. But Sagittarius A*, 4 million solar masses, 12 million kilometer Schwarzschild radius. When you cross the event horizon, the gravity differential between your two ends is too small to feel. Tidal forces cannot harm you at all. You cross the event horizon intact, then continue falling. This is the last ironic gift the supermassive black hole has waiting for you. Approximately 11 hours after crossing, in your subjective time, meaningless to any external observer, you approach the singularity. From here, tidal forces begin escalating exponentially. At the endpoint, the gravitational gradient approaches infinity, and every individual atom in your body is pulled in a different direction. Not an explosion, not combustion, mathematically infinite stretching. General relativity loses its predictive power here, because the curvature at the singularity is infinite, the equations output infinity, and the rules of physics themselves shatter at this point. No one knows what happens after. Not because we aren't smart enough. Because the language of space-time geometry has encountered the hard limit of its own vocabulary. Right now, at this very moment, you are on Earth, time flowing at 1 second per second. That rate is the fastest version you can ever have. The closer you get to a massive object, the slower your time, not as a feeling, but ontologically. 1 second inside a gravitational field is shorter than 1 second in a vacuum. Your time has always been compressed. You just couldn't tell. Earth itself has gravity. Your feet are closer to the center of the Earth than your head. Your feet run a few nanoseconds slower than your head every single day. Over 90 years, your feet are about 2.2 microseconds younger than your head. Absurd? Yes. But this is a physically measured reality. Two different rates of time are happening inside your body right now, at this very moment. If the flow rate of time is determined by the gravitational field, there is no unified now in the universe. Two observers in different gravitational fields are not pointing at the same time cross-section when they say this moment. Your now, at this very instant, corresponds to billions of years in the future for someone at the edge of a black hole. Simultaneous is meaningless at cosmic scale. This is not relativistic sophistry. This is the hard conclusion of Einstein's relativity, an engineering constraint GPS engineers must handle every morning they go to work. Your time is local, personal, compressed by gravity. That timeline you thought you shared with all of humanity, that sensation of uniform flow from past to future, is an approximation wearing the mask of truth. Not an illusion, an approximation. At human scales where gravitational differentials are negligible, that approximation is precise enough to build skyscrapers, sail oceans, and schedule dinner. Once the differential becomes non-negligible, it shatters. The universe has no universal metronome. Every mass, every trajectory, every local gravitation